All right, we are back. Zelda's doing a lot of talking. My apologies. Okay, so we talked about we could do graph and check, but I have two other methods in which we could potentially use. And again, you want to know all three methods because I'm not saying you should do all three, but you should know all three because it's not always efficient to use, let's say, graph and check, like we talked about. Maybe the y-intercept is a fraction. I don't necessarily want to have to see what the point is that they're touching because that's kind of hard to see. So you should know all three so you can see which one is the most efficient, and it's also good to check your work. So like I know for a fact that -3, 1 is my answer, but I want to practice substitution elimination. Let's see if we get the same answer, and we should. So for substitution, I think about substituting on a soccer field. So if we're doing substitution on a soccer field, you know that you have one team, let's call it a team, that's starting on the field. So your field, actually, let's talk about your sub. So if I'm talking about my sub, I want to first find what would be the variable that would be easiest to isolate in either of the equations, okay? So this x is attached to a 2, this is attached to a negative, this is attached to a 3. This y would be the easiest to isolate. That's my sub, okay? The other one, that's your field, okay? These are the players on your field. So if y is my sub is subbing in for another y on the field, okay? So this y leaves by, and now it's open. So let me rewrite it with the same color so we can see what happened. So here's my field. I have -x plus 3, and then there's a space because this y left, okay? And we're going to take that space and we're going to fill it with our sub, okay? And our sub is this y value right here, okay? But this y value is attached to all this. I need to isolate it, so I just have y by itself inside of here. So to get y by itself, I'm going to, let's use a different color. So to get y by itself, I got to get away what's around it. So I'm going to subtract this 2x from both sides, and that goes away. And now I have y equals -2x minus 5. So this is what's getting subbed in. So -2x minus 5. And you notice that when I sub that in, this new equation that I'm going to be solving, so the new equation that I'm going to be solving just has one variable. And we can solve equations with one variable. I know you've done lots of this. So I have -x plus, I'm going to distribute this, -6x minus 15 equals 6. And I know I could have just written -6x, but I didn't. Combine like terms, -7x minus 15 equals 6. I'm going to add 15 to both sides. I have -7x equals 21. I know that x equals to -3. So we know from graphing it that the answer is -3, 1. But if I hadn't have graphed it, how would I know what the y value is? So to know the y value, I can simply plug it in right here. So we know that y equals -2 times x, so -3 minus 5. So y equals +6 minus 5, so y equals to 1. So my final answer, -3, 1, and we also know that's true with my graph and check. So substitution, I combined the two equations using the method of substitution, and my new equation, so I took two equations and two variables, and I put them together using substitution and came up with one, so I'm going to put a little cloud around it, came up with one equation and one variable that I could solve. I'm going to use that same idea with elimination, and I'm going to grab a different color so we don't confuse what's going on. So with elimination, I want to eliminate the x or the y, and I'm going to eliminate it by combining them together using addition. Okay, and when I combine them together, so let's just combine the 2x and the -x, I get x, and y plus 3y makes 4y. Those didn't, none of those canceled. So I have to do an extra step, and we're going to talk about that in the next video.